Pandas is an open source, again a floss, okay, it's a BCD licensed Python library providing you to work with the data analysis, data wrangling, and all the data parts, right? So you have got benefit of high performance, easy to use for the data structures and data analysis, okay? So that you can do with the help of pandas. So Python with pandas is used for doing the commercial domains, in the working in the commercial domains, like in the economics, finance, statistics, analytics, and these domains are much of used with this pandas, right? So yes, so for these the prerequisites you must know that is a that is the numpy, right? So I hope you guys have gone through the numpy. Okay, so if we just write down the definition of this, let's say pandas as the floss analysis, handling, or you can write etc. A lot of them. Yeah, first line is having a code, and that is also an error. Good. So that is pandas, right? So the key features, if you go for pandas, the key features, the important key features of pandas are that it is very fast and efficient for the data frame objects and all. Okay, it is very fast and efficient for that. So tools we'll be working here can be a file of JSON, can be a file of HTML, CSV, Excel, and there are a lot of them. Okay, so you can reshape your data sets. You can just make some basic information what you need among from your data sets, right? You can go with the time series functionalities. So there are a lot of things you can do with the pandas, right? So installation is very easy. If you now go for the installation part, the installation part is very easy. If we just say so, again I'm saying for those who are working with this PyCharm, they'll have to make it this by clicking on that plus sign, and will have to install it manually. And for the rest you can and for them only, that you can just write this install your pandas, like that you can write, or you can write it like so you can write it as code or you can write it as someone escape. Okay, some is missing there. One second. Alright. So to working with the pandas, we'll be working with series and the data frames, right? That are basically called as your data structures. So these data structures are nothing but some sort as said to be the series, and many a times most are the data frames. Okay, so this is called as a data structure. Mainly this deals with the kind of this data structure. We're dealing with the series data structure, the data frames data structures, right? So these data structures are built on the top of NumPy array, which means very fast to go on. Okay, so there are dimensions what you have read till now. Okay, so the best way to think of these data structure is that higher the dimensional data structure is, and the container of the lower dimensional data structure. For example, you can say that a data frame is container of series, and it's a container of a data frame, right? Or it's a panel, you can say. For example, okay, these are theories, don't go with that. We'll go with the practical, you'll get to understand better. Okay, so the data structure of dimension 1, that is series. Okay, there is one more kind. I can also call that as panel. So see, so three kind of data structures are there for the series, data frames, and panel. Okay, so data structure of the series. Okay, so series are one dimension ones, and I'm giving it as, let's say, so let's make a set. Let's write this as data structure, and let's just say that this is series. Let's say that this is dimensions, and the dimension is 1. And description. So description would be one dimensional labeled homogeneous array. Okay, so like that, I can be writing it for the data frames too, and similarly for the panels, and this I'll be taking it as a list, and this will be 2, 3. Similarly for this 1D array, we have this, and this data frames are called as a 2D labeled data, right? These are mutable. You can just change the things. So you can say this as 2D labeled. Let's write this as, so 2D labeled. You say it as mutable. These are immutable, okay? Just 1D because size are mutables to them. Okay. And this third one, that is a panel, this is called as a general 3D labeled mutable array. Okay, or 2D mutable array, you can say. Okay, so 1, 2, 3, and this is what they have given as your dictionary ones, right? So you have written all these things. Now, what is exactly a data frame and what are those? There's some dimensions. Okay, so this is your dictionary. Now you all know how to fetch out the data from the dictionary. So like the keys are my data structure, dimensions, and the description. Okay, and how many kind of data structure I am having. So I can just do indexing over this. That is, in the data, I'll be looking for the data. I'll be looking for the data structures. So that is series, data frames, and panels. Okay. So in the data, what are my dimensions? So 1, 2, 3, and similarly, you can go for the description of that. So 1D labeled homogeneous array, 2D labeled mutable array, 3D labeled mutable array. Okay, understood. So to getting this as a kind of a tabular sheet, we call this as a data frame to get just a basic thing on that. Okay, so first let us import this pandas as this PD. Done. Now let's say this is my data frame. Okay, don't go for the logic now. I'll make you understand afterwards. And I'm saying this data as to be my data frame. I'll just print out my data. So what you can see is this is a data structure. This is a tabular form. Or you could better see if I just write here. So this is a data structure. These are the dimensions and the description. So you can see series are 1 dimension labeled homogeneous array. Data frames are 2 dimension 2D labeled mutable array, and this panel are 3 dimension 3D general mutable arrays. Okay. So that is. Now mutability means that all pandas data structure are value mutable. Okay, that can be changed except the series, because the series are you can say this are having one column data, and then you can just change on, you can just do, but not permanent, right? So what are series now? Let's see what are series. So if we come to see what are series, so we say series is a kind of one-dimensional array like structure with homogeneous data. Okay, so let's write this here. Series is a don't like kind. This is one-dimensional array structure homogeneous data. All right. So you can say like homogeneous data means like for 1D array, you know, NumPy 1D array, that you could call as a series for you. Okay, like let's say for example, if you write it as, for example, you just see this one. So for example, you are seeing just numbers over there, that is one dimension. So this is a kind of series, you can say. Okay. So in series, the key points are that it is a homogeneous data, always a homogeneous kind of data, and these size are immutable. Okay, the size cannot be changed on this because it's a one dimension and it will always be a one dimension. And values of the data can be mutable. Okay, so you can change the values, but you cannot change the size of this. Okay, so now we'll try to understand this series and we'll try to build up things in the series, and we'll focus much of that. Okay, so let's see the definitions of this data frame also meanwhile. So what are these data frames? As I said, data frames, you can call it as a collection of rows and columns in your data, right? So defining it would be a kind of two-dimensional array with heterogeneous type of data. Okay, so these are two-dimensional arrays with heterogeneous type of data, right? So you have seen the data frame here, right? That is something more than uh, two kind of data here, right? This is a string, this is an integer, and you can see there. So let's pass these things below. So this is an example of data. All right. Or no, this should be given upwards. Okay. So this is an example of data where you have more than 1D kind of thing. Okay. That is series. Now series would be a part of this column, or series would be a part of this data, like a part of a column or a part of description or any of the kind. We'll study it there, right? So these are your columns and these are your rows, and these 0, 1, 2, try to understand everything there. It is 0, 1, 2 are your index values, okay, of this things. These are the columns, these are the rows. Understood? Like similar the panel is a 3-dimensional data structure with heterogeneous data. Okay. So we'll try to understand the series. Okay. So let's study the series now. So series can have any particular type of data. Let's say it can have any integer, it can have any string, float, Python, objects, or like that. Okay, it can have anything there. So in Pandas, when you try to make a series, you will have to follow a particular syntax over there. Okay, that syntax is called as if you have imported as PD, so that will be PD dot series, S capital, and then you will be writing your data. You will be writing your index. You can write your D type. You can write the copy and all these things. So most probably we use these things. So the syntax of writing a Pandas series, PD.series, you can, if you are just importing Pandas as import Pandas and not writing as PD, so you can use as Pandas dot series, and then you can write on there. Okay. So what are these parameters? So data takes various forms like an n dimensions array or constants or list or any dictionaries or like what you want in your data, right? And this index must be unique, right? It can have any values representing your data. Data D type will be your data type. That's easy, right? So a series can be created with an array, with a dictionary, with a scalar value, with a constant. Okay, with these things, we can also create as well an empty series too. Okay, so let's start with creating an empty series and then with every of them. So an empty series could be created as, okay, I have imported this still. Import Pandas as PD, and let's say this is series 1. Let it be S. Okay. So I'm not giving any data, not giving any index, not giving any data type. Just pass on this and print me S. So it's giving that there is nothing there inside this, and a warning is coming. That's good. You're getting a series empty, a data type of kind float 64. So by default, it is always a float of 64. Okay. Now we can create any, you can say, series with a list, with a dictionary, with any constant values, with NumPy, right? So let's create a series from a NumPy array. Okay, so let's say S is equals to, we have imported NumPy or not. So let's say S equals to np dot arrange. Okay, and let it be A, B, C, D. Okay, so this is my S now, and let's say VD. No, don't take it as an S. So this is my data, it is np.arrange. Okay, and that's all. I'll be just printing it out. So unsupported kind of is an integers. Oh, so what you see that this series is having some four particular data, that is A, B, C, and D, and you can find that 0, 1, 2, 3 is also presented there. That 0, 1, 2, 3 are nothing but the index values of this A, B, C, and D, and the data type I am getting is an object. Okay, that is a combination of strings too. So whenever you are getting a string as your data type, you will be getting it as a kind of object. So you can even modify this as a kind of a list. So let's say you want to build it, you want to build a series with the help of a list. So how to do that? So let's say that we are having some even numbers. That could be, so it's 2, 4, 6, 8, 10. Alright, it's 2, 4, 6, 8, and 10. That's good. So what I can do is, I will be just printing up a series there. I'll be just printing a series. So I'll say S to be pd dot series, and this will be the data should be even, and there we go. So it's 1, 2, 3, 4, 5, right? So let's say now the index values to be arranged to be the 1 to 6. So if we print our S, we could see that this data is having 2, 4, 6, 8, and 10 value. That is your even, and this whatever you're given. And the index, instead of getting from 0 by default, instead of getting it from 0, what happens? It is getting from 1 to 5, because I have assigned index to be in a range of 1 to 6. Okay, so that is, you can write on. You can change your index values. Similarly, I can change my index values if I add on this here, right? I can just write on this like copy this. So you can have your index values as, if I run this one, so you'll be seeing A, B, C, D, E, and then place this as the values. Okay, cool. So Let's make with a dictionary. So with the dictionary, you can see your data would be like, let's say, so in the morning in the Python class, we have done some sort of nested dictionaries. Let me bring from there. Yeah. So this was our dictionary, a kind of nested dictionary. So let's say that you are having this. That is, we just made a data of some batting average of Indian players. We just fetch out a data from some website and then we started making a nested dictionary of this. So we made, let's say we made a data over there, and this is the kind of a dictionary, and this is my dictionary now. So now I will make a dictionary with the help, I'll make a data frame, or I'll make a series with the help of a dictionary. Okay, so let's say that this is an S and this is PD dot series with your batsman everything, and then you can check on your S. Now your values would be very good, right? You can see your values as that player is having some these much values, the span is having these values. Similarly, this matches, innings, the NO might be something I didn't came to know what is this. This runs, and it could be number of out or anything. HS, I think it's highest score, average. This I don't know. This is strike rate, this 150 and so on, right? So we have all these data, right? So you can get to your S, and you can meanwhile you can search for your any particular data. Let's say you want the players. So you want the players, you can go with the players. If you write it as, okay, not going like now. So you can add on things, you can just print out anything here. So this is your S, right? You can see that this is a data type of object and you're getting it there, right? So you can do a lot of things with the series. So let me give you here an idea again. So series are a one-dimensional labeled array. That is, you can see here. So these are the index values. These are the values we are having. So particularly write this as pd.series. You write the values first, and then you pass on the index value that can be having some index and the values there, right? So let's first complete the series, and we'll go to the data frame part. Okay. So with the help of a dictionary also, you can see we have seen that we can just to work, we can just make anything from the dictionary, or we can make a series from a dictionary, right? Similarly, you can make it from an numpy array 2 or like that, right? You can do with anything. So let's say that I have made a series. Let's say this is S1. And I'm saying my data to be 1 to 10. And let it be the index, anything would be there. Let it be anything coming. So let's print S1. So this is 10 to 20 numbers, and then the ranging of the index values I'm getting, right? That would be fine. Okay. Now let's take similar S2, changing some values now. take it to 36. Yes, you can take it back. Okay, so this is from only the 5 numbers, right? And there you are having now 10 numbers. Now what we can do is we can add on, we can subtract, we can multiply, we can divide the series with its own data. Now how these operations are done, let me give you that. See, so operating basic operations of arithmetic thing, right? So what you can do is you can just say that, you can say it like you want S1 plus the S2. So you're getting the values, that is 40.0, 42.0, 46 and all those. After the 5, what has been done here, that every value is coming as a NaN. Now this NaN states that there is not a number, it is not a number over there, there is none number, nothing is there, okay. Even the 0 is not there, there is nothing, the blank space is that, okay. So why it is so? Because see what happens, this 10 would be added up with 30 and will give you the value. So till 5, every number will be added up similarly and will give you the value. After that 5, when this S1 is supposed to add on with the S2, it will search for a number for the 6th position and it finds that there is nothing, right? There is nothing from the 6 to 10 in this S2. So nothing to add, so there is no values, right? So that is NaN. When you got NaN, you always make it sure that you have nothing values, right? That is 0. That is not, sorry, that is not even 0, okay? That is blank space. So don't consider is that there is NaN, so that is a 0 value. That is none there, right? So we'll go to the batsman one later. Okay. Then you can access the data from your series, right? By giving their position values and all those. Okay. So let's say I want to retrieve the first element. Let's say I want to retrieve my first element. So what I'll do is I'll say okay, so from the first element of I will say from the first element of this S2. Okay, so what I can write is print S2 of 0, that is 30. Understood? Then normal indexing, what you do, right? So you can also retrieve the information side. Now let's say retrieve the first or the last 3 elements. You would simply be writing in the S2 you want every elements, the last 3 elements, right? So that is from -3 to everything. So the last 3 would be 33, 34 and 35. Okay, so basis on your indexing on you can do or find all the things there from, right? So you can also retrieve the data using the labels. You can write the labels and then you can retrieve the data from using the labels. Let's say even if we have done any labelings of the data there as kind of, so let's make the data and then we can even if you don't write data, it is manageable there. But make sure that you will have a good habit of writing that. Okay, that's good. So what I was saying that you can even index your values. First let's print S, that is good. So you can index you can just go with the indexing method with the labels too. That is, let's say this s of a. You can find out the values by just indexing there, right? So you can even find the multiple elements at a time, right? Whatever you want. So for the multiple elements, you will have to give 2 brackets, right? So let's say what is this? So to retrieve multiple elements from it, that might be a form. Okay, so to retrieve multiple elements from a series. So for that, you can just write it as print, and that too with the labeling. If you want, you can just write it as s, and then you can give one more bracket and then a oblique whatever you want, c, or again a. You can get your data like that. Okay. Fine. So if something is not present and you are labeling that, so that will be raising an error for you. Okay, that will be giving an error. So this is all how you can work with a series, how you can get out with the data. So similarly, I can give them multiplication, subtraction, and all these values. So you can just pass on this s2 multiplied by s3. And you can see the first 5 values. Sorry, that is S2. You can see the first 5 values by, you have to write it as a multiplication, let's say m, and then you can just pass on this. You can see it kind of, why it is not getting there. Alright. So you can, so rest of them are the nothing, right? So that is, it is not having any value, so it's same, right? So you can do division and all those. So for finding some statistical data, like let's say you want to find the mean, median, or let's say find mean, median, let's say some maximum, minimum, like that. Okay, so what you can do is you can just write mean of this m. So that is MP, right? MP. So we'll give a nan value because like you have a nan values there too, right? So you can find it with a good like a good data which is not having any nan values. Like I think S is not having any nan values. Yep. So you can find out the maximum of this S. That will give, find out the minimum of this S. Find out the mean and more medians, right? So you can find these two, right? You can even find the sum. Two sum is let's say. So you can find the sums, right? So this was a part of a series, what you can do with the series. So that represents one-dimensional data, right? Now we'll go to understand about the data frames. So as said, data frames are a two-dimensional labeled data structure with columns and some values, right? So if we just copy this and we'll just paste it there. So we'll be seeing exactly this as the same. So this will be your columns, this will be your index, and you will be getting like that. Okay, fine. So let's say this. Remove this. So this is saying that this is the data of country having this and this, so much, and then the population is like that, right? So you are saying that df to be a PD of data frame, that is PD.data frame. Make sure that every time in the series S is capital, in the data frames D and F are capital, and you are making data. Your columns are data. Your columns are country, capital, and the population. That's good. Okay, you're saying this as your columns there. So you run on this, and you see the data. So that is like what you saw here, right? Exactly the same. So what you saw, that is the country, capital, and the population as your columns, and 0, 1, 2 as your rows. Okay. Now, if you want to get a series, or if you want to get a series, or you want to make a column as a series, so what you will do is you will just pass on. So you will be just passing on df, and then write, let's say, capital. Let's write population, that's all. So that will be a series of this, right? You can see like that's same 0, 1, 2, and the values are there. And the name of the series is now the population. Still here we don't have any name of the series, right? Only the data types are there. And the data type is an integer of 64 bits. That's clear, right? So there you can work off with the like kind to make a particular data frames there. Okay. Similarly, going ahead with this, now this data frame object contains, as I said, you have syntax in the data frames as so there you have you write it as PD dot data frame, and you pass on your data, you pass on your index values, you sometimes pass for the columns, you pass the data types, right, and index columns too. Okay. So this is particular a syntax of, right. So you can create a data frame with sets, with lists, with numpy arrays, and any kind of things. You can create a data frame with any of the things. Now, so you can see like kind of thing, like we have made this, right, and we can just create any series with the help of any column. So we'll not be working with just only this kind of data. We'll be looking with a lot of data, right? A lot of data means good data what you have. So for a good data, I have made this as a kind of morning. We have made this one, this dictionary. There is pat average Indian players. When you look on this data is very good one. So let's say this is a batting everyone. Let's take it as DF only. All right. So let's say create dot data frame of this players. All right. And then you print DF. So probably you could see all this data, right? So this is having the data. We took around almost 15 to 20 minutes to make this one. This took a time there to work on. So this is a data of batsman average, like some normal data that taken from the ESPN cricket site. Okay. So we have this players, the span time, the matches, innings, and all those things, right? So this is our generated data. Like we generated with this with the use of a dictionary. Okay, we generated this data with the use of a dictionary now to see. So see guys, so the first thing in the data is whenever you come with a data frame or whenever you have any data. So the first thing is that to look on the first 5 values, first 5 rows of your data, what you use is the method called as head. It is df dot head. So this will be giving me an idea of how my data looks like. Okay, so I'll be getting some 5 values only instead of all these things. I'll be getting only the 5 values, and I can get to understand what my data actually contains on, right? So similarly, to look on the last 5 rows, of your data, you'll be looking for df.tail. Alright, so df.tail will give you the last 5 values, and the head will give you the first 5 values. Okay, that's simple. Now see, now let's say you want to see the first 10 values, or the only first one value, only the first column, or only the last column, right? So what you can do is, you can just like for the last column, you can just pass on that tail of only 0, 1, tail of 1, PD, this is df. So df of tail of 1. So you will be getting only one particular value. Similarly, for only one upper value or only one first value, this is df.head will be giving you the only first value. Okay, and the things you are seeing 0, 1, 2, 3, 4 are nothing but the index positions, index locations of that data. Okay, so this you can get it at. Now what else you can do is, the first thing is like you can sort out the values with your data. You can just check on how many columns are there, how many information. So for getting the informations of our data, you have a function called as. Now let's see one by one we are looking to this. Now we are working with the data, not like we are not just, let me bring this. Yeah, so we are not going to just like read the data now. Okay, we'll read it, was first complete the methods how to go with that. So there are methods for selecting, for positioning, for labeling, and there are a lot of things. So before writing and all these things, what I will do is arithmetic operations for the series and all those, right? So first of all, what we'll try to do is, for getting the information, for getting a general overview, you can say, for an overview of your data, what you do is you just write info. So this will give you an overview of your data. That is saying that this data is a class. Okay, this is a class of Pandas code data frame. It's saying that there are ranges. The index ranges from 23, that is 0 to 22. It is having 23 entries. That is total 23 columns. So 23 rows, each starting from this 0 to 22. Data columns are having 15 columns, 23 rows. Okay. The column names are player, span, mat, innings, and all these things. Now every column is having some every column is having some 23 non-null objects or non-null values, you can say. Okay, so data type, like in the player, we already have this strings, right? So strings as object, as I said, that apart from integer and float, everything you'll be getting is a kind of an object there. So this is matches. Matches is having an integer value, that is you are getting. Okay. Similarly, you are getting everything there, the data types of all the columns. Now the data types used in the whole data set, or the whole you can say the whole data. So data types used in the whole data is float 64, that is only of 1. Integer 64 has been used for 11 times, and the object has been used for 3 times. And this data is having a storage of 2.8 KB. Alright, and if you want to see the location of this data frame, so that has been located in this particular address, that is the ID of this data. Okay, so to see that, you can find it out there. Okay, so I can write this to find the location or you can just write as print the ID, and that's it. Okay, that's cool. Now this was an overview of your data. Now if your data is having some very good good numerical values, when your data is having mostly the numerical values, or mostly the data types of your data set is integer or float, right? So I can see my data is mostly as an integer and float one, right? Only 3 are there and the 12 are the numerical values. So if the data is having mostly the numerical values, you can pass on the things for getting the statistical description of your data. Okay. So to get the...
So can't use the same ID process for checking the location of a series?
You want it to be printed as... Okay, so to get the statistical data, got it?
Yes, sir. Yes, sir.
So to get the statistical information of a data, what you will have to do, so there you will be using the function called as describe. That is called as descriptive analysis. Okay, so you write df dot describe, and you will get some data of the whole columns. Now look carefully what is there. So this says that every column is having some 23 non-null or 23 values. Okay, this is a count. Now the maximum number of the matches of some player might have played, that is 97. Similarly, the maximum number of innings in this this innings column, the maximum number is 145, and the maximum number of runs one player has made in his innings there in 145 innings, it's 7240. This might be a data of someone else, right? That is not only for this innings and the values, right? So this could not be related with this all, but this could be related with this index, this column, right? So max number of runs is this, max number of highest score is this, maximum number of 6 is this, okay, 4 is this, and there, this is the values you can get. You can also get the standard deviation. We read yesterday, right, what the standard deviations are. So there's the standard deviation of your particular columns. This is a 25% value of your columns, 50% value of your columns, 75% value of the columns, and this is how you can get a descriptive analysis of your data. Okay, so you can find out various things from your data. Now, okay, these things are over, right? So now you can also check how many columns your data, how many columns your data. Apart from this, we saw here that we are having 15 columns. These are the columns names. But if I don't want to write the information, if I just want to see how many columns my data frame is having on. Okay, so for that, let's say to find, okay, to find the number of columns in your data frame. So to find the number of columns in your data frame, you will be using a method called as df columns. That's all. So these are your columns. That is player, span, mat, innings, now number of runs, HS, average. What is this? I don't know. SR, 100, and all these things, right? So these are your columns. Similarly, to get the index number, or to get the index values of your data. So to get the index values of your data, you will be just writing the data frame name and then the index. So the index is, first of all, you see the index starts from 0, stops at 23, and goes with a stepping of 1. Okay, and now we'll see the index values. Index dot values. So the index values are from 0, 1, 2, 3, 4, 5, 6, and all these things, right? Similarly, you can find out the columns and their values. So columns you have find, right? So what are the values of the column? To get the column values. Okay, this is very simple every time. Just a bit of a basic concepts you have to remember. That is, you want this column. So these are your columns, and you want the values of this. So values of the columns is saying to be this nothing but the player span and all these things, right? So not getting the values over there. You can just write on this as df dot values, and you will be getting to it. That is your this values. So your these were your columns, right? These were your columns, and these were your values. That is df dot values, and every particular values is being generated here, and you can see on this, right? So these are your values of your particular data. Okay, now let's say to see whether any null values exist in your data, right? Null values means that your in some of the points might be there could be a null value, that is any non value or anything not present there, right? There might be happen. Okay, so for checking that, we'll be writing it as df dot null. Let's see the first 5 values. Oh, sorry. So I can see everything as false, right? So false states that there is no null object. I'm checking for that df is null, whether the df is null or not. If it is null, then give me true results, and if it is not, then give me some false results, right? And I'm getting a head up. If I would not have given this head, I would have get all the values, and I could see everything as the false there, right? Now this is discrete values and very important for this. Okay, so you can get it like that. But in case if you write df is not null, then you will be getting some true results, right? A not null value. So these are not null values, right? These are not null values. So for the null values, you can just go, and this is for the not null values. So checking for the not null values, and you will be getting it to it. Okay. And meanwhile, you can also check for the sums of this. If any particular, you can say data is having your null values, or any particular column is having a null value, you can find it with the sum, right? Let's say df dot is null dot sum will give you a description that whether this is having any null values or not. Similarly, you can find out for not here. You can similarly find out for df not null sum. So you see what comes. So for the null, we see that there is no null values here in the data, and the not null we see some 23, 23, 23. That every particular column is having some 23 data over there, right? So we can also see a graph of this all, like what would see whether this is how it is. So for seeing a graph, what you can see is, okay. So what we'll do is just we'll plot a heat map. I'll be giving you later on what is a heat map. So you can just plot this heat map of your data as df dot is null. Okay, and you can give your C map to be cool, warm. Let's say to be blues. Okay, let's go with the oranges. So you can see what is there. So that is good one. So meanwhile, if you have come to see that what are the possible values which color map could have. So these are the possible values. What you can do is store these values. Okay, so that is also important. It's good that we have got the errors. So because many a times this makes an error. Possible values for a color map. There is a C bond. Color map. So let's do one thing. Okay, now that could be an issue. Storing all these things, right? There are a lot of values to making this an MSTR. What to do with that? Where is this blues? There might be capital blue, I think. Yes, this capital blue. What to do here? This is all around. Okay, let's make it markdown. That's good. So these are the values which we could have it, or you can even make it as NB Robert. Possible values for color map. Let it be marked down, please. That's good. So we'll see it with the blues, that is capital B. So what you can see is that here is a basically a heat map. This heat map states that these are the columns here. Okay, we'll discuss in the C-bond that these are the columns here and these are the values. So greater the value, the you can say that zero. The zero states that this is zero. Now you can see the color of zero and this color of this particular box. So they state that there are no null values. If there would be some null values, the color would increase on there, right? Okay, so no null values are there, right? So let's see about the oranges, how it looks like. So color plates changes according to your data. So you write your oranges and right, there are a lot of color plates. You can take any one among them, right? So try all of them and see what is your favorite color, right? You can go with the summer. So it's an autumn night, right? Let's go with the autumn. So that is good, right? So you can go with your own data, and I like orange and yes, all red and yellow. That's good, right? And blues too, right? So there is a cool warm kind of cool warm. That is also a good one. There you might see cool warm here somewhere. Where is this cool warm? Okay, let it be there. So these are the values, right, guys? And you can pass on these things. Okay, anyone having any doubts there? Fine. So you can pass on this area of the, yeah, there is a cool one. So you can pass on these values to find out or make it sorted. So these are in the sorted, I think. Okay, there is PUBG or what? This is what PU. Okay, I haven't tried this way. PUBG. Alright. Fine. So this is how you can just plot a null. Similarly, you can plot it for not null. So not null graph would be similar as like, because every values are true, and you for true every time you will be getting this graph. Okay, that stays for this, right? Moving ahead now. So this is how you can check a color, like you can check out whether a data frame is having any null values or not, right? So these are important things, right? After then we'll come to go for the indexing and all things. Now we have seen how to find out the index, how to find out the columns, how to find out the your series from your columns and how to find out to get out the data. So we have done all the basic parts now. Now we'll go for the indexing and all those things, right? So let's say that this is the data, whatever the cricket data you have, right? Whatever the data, what the columns you're having, this all. Slicing over the data frame, right? So let's say that to get the specific columns, to get out the specific columns, if you want only some particular columns you want, right? So if you want some particular columns, you can make it there. You can just index the values and then you can bring out, right? So let's take, let's say you want only df of so you can search on for this here all the things, right? For selection you can just write on like here and then you can get it for help, and then you can write it for help series.locate or like anything, right? So you can use these things to find all the values too, and indexing and all those things going on. So let's say I want this data. Why it is not going downwards? What is happening there? What is this? How it came? So let's say we want so to get only the data, only the columns of this will can write at this, and then we can also pass on this head to see only this. So we have we want only this innings, the NO and the runs. So we got all like that. Yeah. Okay. You can write on, let's say we want only the matches and the runs scored, the matches, the strike rates and the runs. So you'll be getting the matches, the strike rates and the run. Meanwhile, I just only want the player name and their matches and their strike rates and their runs. So these are the values of this I'm getting there, that is right. So you can just slice these things. So that is kind of very basic what I have done here, right? So you can find out the values like this. You can do indexing and this all. Meanwhile, if you, let's say that you want to just do a column selection. This is nothing but a column selection, right? So you just pass on a column and then you can just get a column selection. Similarly, you can do it for the rows if you want some particular rows to be inserted, or if you want some particular rows to be getting out there. So you write it as so that will be locating only the 0, 2, 3, or let's say 15. So we'll giving you like that. There's, let's say for 12, 11, 5. So what you'll get it as, it's a kind of a rows. So to get it from a column, to get a specific column, so you can write your columns over there. Now to get a specific rows, we'll have to use the LOC method, that is location, right? So to get the specific rows, okay, you can pass on this and you can just get. So how I get this 11, 15 and 5, this is what, because these are my index numbers and location is always based on the basis of location, this index number, right? You can meanwhile also pass on the values and also can find out which is having. So this is now because there you have done indexing, so that is why it will give you an errors. So not going with that. So you can just find out the specific rows or the specific columns according to your data, right? You can do any. Now let's say if you don't want any particular data to be given there, so you can delete it also, right? You can just delete that particular data. So that is important to like doing the selection of these things. You can also get the help by writing on this vd dot data frame. So this help particularly states that the main features of the pandas and all those things, right? So arrays, and if you want more help for that, then you can just write on. Okay, yeah, version I forgot to give you the version info. So see, for getting a pandas version, so see your pandas version, what you can do is you will be just printing out so mine one is 1.0.1. Your should be also 1.0. So let's bring some of data now, right? And then we'll do some of the analysis on that data. Okay. So till now we have seen. Now see guys, to load, that is to save or load any kind of data. So you can use this save to save on the data. Or this is numpy what I was thinking of. See, now to read any data of any particular file, let's say a CSV data, okay, or let's say to for reading you can do this. For converting a data, you'll be using this TF2. So that is read and write. So you can use this one, or you can do it. So I'll be doing one by one, and then you will be getting it to understand very clearly. Okay. So see, this IX is used to select single rows of subset of rows there, and this LOC select single row, select single value by row and column names. Okay, have been given here like so. Here we're getting this values and like that. Okay. So now let's see to just come up with addition, and let's make some data and then we'll add up some things to that, and then we'll. Okay, so let's come with this one only. That is your country data, the small data over there. Okay. So we'll not go with today with the huge data sets. So let's say this is a data now. Okay. Now to add any column, your data, what you can do is we'll be using the methods, the basic methods to there, right, to add on these things, right? Let's say this is my data, that is your DF now, all right? So I'll be seeing now this is only a sort of 3, so I'm not printing the head and all because this will only give me 3 data. Now I want to add one particular more column, right? What it could be, let's say this could be the, we could add on we can write the Belgium plus 32. Okay, so we'll be adding on this that is TF, be saying that this is a country codes, and we can then pass on the values to it. Okay, you can define this and then you can just pass on the values to one by one. So let's say this would be as if columns, country codes are there, right? So let's say plus 32. This is plus 91. Browse it. 5. So if I see my DF, I could see some country codes over there with some of their country codes, right? So that is how you can just add on any columns just by using this, right? Similarly, you can add rows too. We can just add on rows. For adding rows, you have to expand your data, that's all, right? So you can delete also, right? If you want this data not to be given there too. So for delete any particular data. Sorry, not data, it's column. So to delete this from your data frame, you will be just writing up delete. Write the data frame names and then you pass the values. That is, I want this country. What is this? Codes. I want this country codes to be deleted. And then you can just check on your DF. So you'll be seeing that this has been deleted. Okay. This is how we understand to our data, right? Now we can even give some row selections and the addition or deletions. So for the row selection, what I said is you can just use this LOC method to find out the data. As similar that we could see from here that here it has used this. Let me give it a copy and then I'll paste it over there. So let's see. So it's saying df.iloc 0 of 0. So what that actually means that, okay, so this actually states that you are trying to print the 0 of 0. That is your 0. That is your index location of 0, and that of 0 is the Belgium. Similarly, it says to be 0 at of 0. So when you run this one, you see what is there. Some invalid syntax, yeah. So you have to remove this. Index is not working. Okay, remove this. So you will be getting the Belgium, only the Belgium area. Okay, so what there are some lot of things to see, but what is this IAT work on, right? So that is an indexer you will be getting on. Okay, so there are a lot of things. So this AT, or you use IAT only if to get a single value in a data frame, right? So many times there could be some errors, could have some errors many times. That is not okay. So this IAT particular, what the thing there was that IAT access a single value for a row column paired by an integer position. Okay, and when an integer position is out of the bounds, you will be getting the error. So I don't know why it gave the boundations there. What is it was written there? 0 of 0, right? Yes, coming there, that's good. So that is written incorrect there, I think. So to get on the particular value, you can use this like that. Okay, don't need to write it as. Okay, so you can find it out with the use of ILOC. So this ILOC is used. So there are a lot of method, guys. There are we study these things basically in the called as your libraries, right? So this ILOC, if you say ILOC, this ILOC is particularly, we say this is particularly used to just go for the integer location based on the indexing. Okay, purely the integer location, right? So it gives your inputs like for the writing on the first row, and then for the column values what you are trying to get it. So you can write your columns, and then you can find your index locations with respect to that, right? So similarly, you can work with a lot of things are there to work on, like with the datas. Okay. So this was a kind of an index location. If you want to find out the index location, I forgot to write the heading over there. To get the index location of your data, use ILOC, right? This we don't use for much time, but it's good to use that. Okay, so that is for by index selection. Okay, you can slice the rows as I said. You can just write on like this. You can also write it as for so to slice on the rows, what you can do is you can just write df, and then so from 0 to 2, and like that you can just find all these things. Okay, so how to add on those things, how to just give some addition to it. Let's say population of 12.65 crores. Good. Russia 14.85 crores. Okay. It's 12.65. So let's say to add the rows. Now these are the basic things, right? Because if you don't know to add on, to delete, and to do these things, right? So you will not be able to visualize your things properly. So to add on the rows in the data frame. So today what you do is you just practice only how to add, how to delete, how to index the values, how to make data frames, and right. So you will be doing all these things today. Just practice with the datas, make your own datas and work with that. Even if I will be also uploading some data sets there in your drive, so you can work with that. So to add rows in your data frame, what you can do is you will be appending the values, like let's say you will be doing it like df is equals to df dot append, and then you can write, let's say you are making a df1, and you're saying that this is a pd dot data frame where, let's do one thing. Let's make it as let's just copy this and we'll paste it here. Okay, so now I'm saying that I want only the two countries. Let's say I'm taking for this Japan, and I'm taking for this Russia, and the capitals are Tokyo. Oh, that's good. The name, how's the name? Same, the capitals length are same. I think 1 2 3 4 5 6 1 2 3 6 2 3 5 2 3 5. That's good. Let's see the populations. Population seems to be 12.65 crores. What about the Russia? It's, let's say this is 14.45 crores. Okay. 14.45 crores. So T2 varies. So what about this? 2016 is 14.45, 12.65, 14.45, 12.45, 12.65 CR. Okay. So this is your data frame, and you write this to be D2. The columns you have given there, and what's your data? So I think this has been done. So to append the values to PF1, let's see any errors comes or not or done. So we'll see our DF. Now I can see here two more appended values. That is the Japan and this Russia as a capital and the population over there, right? So you can use this to avoid this indexing. We'll re-index these things, right? Because this indexing will have some wrong values there, right? So we'll be re-indexing this data. We'll change their index values. We can do those things, right? We can also convert this now to as a CSV file or as a Excel file or anything you want. It's a kind of a JSON file or HTML file. So that all thing you can do with this data frame, right? So let's say that I want to just convert this data. So if we want to see a graph between the country and the population, if you want to see the graph between the country and the population, so we can just plot it. No, that will not be good because we have only one numerical values, right? So that will not help us much. You can find it as count plot, sns.count plot if you can give the data to be your df, and you can write x to be the population to be counted on, and that will give just a basic graph. Yeah, so you're getting a population of this. If I give a few semantic, that will not give it as such, probably errors. No. So this stands for Belgium, this stands for India, and all these things, right? Like that, you can get the data, right? So this is not a good one, right? Because there are some insufficient, very less data, so you are not getting a good graph over there to find out, right? So removing this. Okay. Similarly, you can, what I say that you can just change your data to have values, to have this values to any format of Excel or like that. But before that, let me give you an information of this random function, what you have read in the NumPy, right? So to get a random generated, let's say, data frame. How do you can get a random generated data frame? It's easy, right? So what you can do is just pass on this random name and then write np dot random dot rndn of 5. So we'll see your RAM. So this is 5 random numbers, right? There are 5 random numbers. So similarly, what you can do is you can pass on this rand. You can say this to be random dot random, and in place of 5 you can write on this as 25, and then you can reshape this 5 cross 5. Then you can see your RND, and this is a 5 cross 5 of this all things, right? Then what you can do more is that you can assign some names to this column, right? You can assign these names to this column. So what you will do there, you can also find the dates range, that is pd dot date range, and you can find out date range as, let's give it today is Saturday 1, no, today is 1/8. And this says that this is the date range, particularly the start and this end. You define what is the start, what is the end, what is the frequency. So you can write on like this, and then you will get out the data. So your frequency, your periods will define what end till you work. Let's say I'm copying this one. So this will be the output. This will be the output you will be getting on. So let's say I'm getting a date range. My start date is, let's give it as 2020. So let's write our workshop starts from 27, and today is 1/8. Wait. Good. Okay. So what is the dates? What are the dates having there? So when you see your dates, it's kind of a date range index, and something is missing there. So do one thing. Could not convert the string to the timestamp. Cool. 27. Cool. So this is the format here in the basic Python, right? You have to first write the year name, then the month name, and then the date. So what I have done is this: I have plotted, I have just printed the data that is from 27/2020, the 7 dates or the 12 dates to be printed out. So today is the 13th, I think. So here, similarly, you have printed all the dates from this 20 August until the 1st of this, so 20 July to 1st of this August. Okay. So these are the dates here, right? So that is a data type of date time, right? Date time library you have read, right? So that is what of containing this, right? So here we are having some 5 columns. So let's let's take up to the 5 values. Okay, these are the first 5 days from your start date, and let's take this columns to be A, B, C, D, E dot split. All right, so let this to be the calls. Now I'm just plotting a random figure. So our data is the random value. Our index values would be our dates, and our you can say our index values would be our columns. Sorry, not the calls particularly, and our columns would be the dates. So you can see that is your data would with the different dates and the columns over there. So for that, like, we can reverse this as, let it be dates. This be, so the dates and this columns and the random generated data, right? So you can generate it like this, and you can write that in some particular day how many like codes or how many like data you are generating, like, right? So this can be also used again with the OTP like section for those things, right? How, let's say you are generating some 10,000 datas, right? And you're reshaping this into 100 cross 1000 cross 10 data, got it? So you're reshaping like that. So when you see your RAND over there, you'll be getting some 100, 10,000 rows, and then this is the sum of the, right? Okay. So let it be as it is. Okay. Now these are some of the random values, right? So let's do one thing. Let's take it from rand int, and that will give an int is not having any. Yeah, that is a problem. What you can do with that? Go with dot. Okay. Okay, fine. So this is okay. Code's done. This bit done. So np dot reshape this to this as the reshape of 50, and there we have a range of random numbers. And what is the length of all this? Alright, fine, done there. So good. Let's create a data frame and let's see if it can keep values there. So data is the codes, okay. The index values are the dates. Now date should be also up to the 1000. That should be make sure that the dates should be up to 1000. 1 minute. So for dates, where are the dates? So 1000 ranges are there or not? Okay, length is 1000, fine. So we can give the index to the dates and the column are 10, right? So let's see. This columns we call what is this? See what is. Alright, done. Fine. So this is G codes. And let's see the head of this. So I can see like in the some particular date, some codes have been generated, and then you can like do these things. Okay. So think of anything like want to make any stuffs, and then you can make it there, right? So this is the head of like on the 20th July. I have generated these much codes there, right? On this 20th July, I have generated these much codes as similar, right? So what else? This is not looking very good there. So what we can do is let the index to be all right. So we have 10 dates over there. Let's make it as 10. Let it be the columns to be the dates. The index we could arrange it as np dot arrange as 1 to the length of data. If it could manage. What is the problem? Indices imply 2 by 10. All right. So let's give it as. So we want an arrange of some length starting from the 1. Okay, let's take it from the from the starting, whatever it is. So let's give it as a head and all. So they're saying that on some particular days, that is from 1, 2, 3 on this 27 2020 we generated some of the codes. So what are the codes generated on 27 2020? Okay, so what are the codes of the 27 2020? We'll write it as 2027 and 20. So these are the number of 1000 codes generated on this 20. Okay, so you can just print on the values, and such like you can just work on with data, right? You can make your own data. You can just write down the things. You can even just can generator. So this most of the users when creates some projects, so they use these kind of things for their particular you can say as data, right? So let's print out the values of this, so we can find out if we can print the values of the codes dot the values. So we'll see that these are the values of that one day. So these are one day values of some 999 values, right? So we will also see the unique values. So we'll see the unique values, not the values. So there are some of the, we also see the length of this uniqueness, and we'll come to see in one particular day if there is any repetitions of the codes or not. So we could find that among from 999, the 988 is the unique. That is 10 in the day 1, or you can say on the 7th or 20th of July, 7 or 10, sorry, 10 codes, yeah. So 10 codes would have been repeated on, right? So like that you can just get it out there. And what are the codes which has been repeated? That also you can write, you can just count on, right? Because we have seen how we can check on, right, let's say X and Y. And that could be a unique of this. That could be a unique of this data. So you can even write it as like this, copy, and then you can just paste on. That is your G codes, that is unique, or you can just write on that np dot unique of G codes. You can just pass on like this, and you can say what are the counts of the data. So this X will give you an information. This X will tell you that these are the unique codes, but we want this Y. So this says that we have some discrete values a lot of time, but sometimes there are 1 and sometimes there are 2 also. So we'll find the uniqueness in Y. So Y says that it's 1 and 2. Alright. So unique data, it's saying that we have most of the time as 1 and most of the times as 2, right? So let's see how many are there for the 1. So we'll work on for where, and we'll search that where this Y is having is equals to 1. So we have till 987. So these are the index values we are having. Okay, similarly we'll check for the Y how many times this 2 has been. So these are the places where we have the codes repetitions, right? That is 1, 2, 3, 4, 5, 6, 7, 8, 9, and these 10 spaces where the codes have been repeated, right? For 999 we are getting, right? So you can find out the index locations of those things. Like you can print on the X.
Sir,
yes?
Sir, in the output 1 and 2, what does it represent?
Where output 1? This says, okay, so when you try to find out the Y, when you will search for the Y of this, let's say for the first 100 numbers, so we can see that there has been some Y, some 1 and some 2. That is nothing but the occurrence of your data as 1 and 2. See, we have some data of these Google codes, right? We have some these G codes, and what we have searched on, we have searched for X and Y, and we have said that the unique codes of this and the Y to be the return counts. Return counts state that your uniqueness or whatever you are getting in a unique value will represent that how many times that code has been or you can say generated. Okay, so this Y will give that return count of that particular code. So it's saying that on the second position that code has been printed for 2 times, right? Like that you get the values. Understood?
Yes, sir.
Okay. So 2 stands that the code has been printed for 2 times, 1 stands for the 1 number of times. So like that you can build your own data, like you can just make with this. So this is a small data I have generated. That is, if you could see the data, that is your df, not df, I think it's g codes. So g codes dot shape will give you, that is 1000 rows and the 10 columns there. You can even find out the null values, right? The uniqueness values will be done. Null values are not there. So what you can do is you can search for, okay, uniqueness is fine. So there is no uniqueness. So you can also search for whether any values having such things or not, maximum values and all those things, right? So this is how a this is how a data sheet generates every day, not every day, like in every particular minutes or every particular hours there in companies, right? This is how it generates on to make, so to make a just a like every random number or every code you get is also stored in our system, so that whenever the public raises a dispute that we haven't got the particular code, so we can just check on whether the code was supplied or not, right? Like that. Okay. So this is how you maintain your data. So this is today what we did is, today we did like building on our own data and then getting manipulation with that, like just adding on and deletion, rows, accession and all those. So you can make your own data set, guys, right? You can make your own data set of your own things. You can just see, you can, what you can do is for bank project, for a project like we used to do the basic one, that's the bank project we do. So what there you can do, you can just maintain our data there. So I have got our data. Okay, now let me stop your recording there.